Good evening, dear students. So we were discussing the topic metals and non-metals. So in the previous classes, we have seen the physical properties of metals and non-metals. So the various properties we have seen in the previous classes. Okay, about the physical properties of metals and non-metals. Okay, what are the exceptions in physical properties? Then what are amphoteric oxides? So these are the important concept from this particular chapter, which we have seen in the previous class. Then what are the properties of ionic compound? What are ionic compound? Okay, what are the properties of ionic compound? Then what are reactivity series? Okay, we have seen what are reactivity series. Then okay, how the reactivity series are arranged, okay, in the increasing and decreasing order. So how it is arranged, based on what? So these all things we have discussed. Then extraction of metal. Okay, extraction of metal. How do we extract metal from a particular series? For example, okay, if you want to what extract a metal from a just a second. Okay. So when you want to extract a metal from a your this low reactivity series, okay, then what you have to do, you have to convert them. Okay, so the oxides of these can be reduced, so they can be reduced to metals by heating. Okay, you have to heat them. Then whenever you want to extract the metals from the middle of the activity series, okay, so which are the metals? Like zinc. Okay, for example, if you want to extract the metal like zinc, so either what you have to do, you have to the metal from its oxide compound, it has to be converted into its sulfide or and carbonate form. Okay, so what are the processes? The processes, there are two processes, namely roasting and calcination. What do you mean by roasting? In roasting, you are converting the sulfide ore into oxides. Okay, and in the presence of excess of air. And what is calcination? In calcination, you are converting the carbonates ore into oxides by heating strongly in limited air. Okay, so here the air is in limited excess. Okay, so as you have seen, okay, in case of roasting, the amount of oxygen required is more. Okay, and in case of calcination, the amount of oxygen okay, the is required is less quantity. Okay, then we have seen what is thermite reaction. Okay, with the example, so this is thermite reaction. So reaction of iron oxide with aluminum, which is used to join the railway tracks, okay, or the cracked machine parts. So this is a thermite reaction. So remember what is thermite reaction and its example. Very important. Okay. Next is when you want to extract a metal from high series. Okay, metals in the high activity series. Okay, so what you can do, you cannot take it by displacement reaction. Okay, so you have to do electrolysis in their molten state. So metals will get deposited at cathode, and okay, and the gas will be liberated at the anode. So here a best example given is of NaCl. Okay, so even your aluminum is can be extracted through electrolytic reduction of aluminum oxide. Then what are the prevention of corrosion of iron? So we have seen what is corrosion. Okay, then we have seen how to prevent the corrosion. Okay, so the different methods like painting, greasing, okay, galvanization, then tin plating and alloying. Okay, then the next was alloys. What are alloys? Okay, so alloys are nothing but they are the homogeneous mixture of two or more metals or two or more non-metals. Okay, so we have seen the different alloys, their composition, properties, and uses. So these were the things which we have discussed in our previous class. Fine. So today we are going to see the important questions based on this particular chapter, that is metals and non-metals. Okay, so your question as well as the answer is given. So I'll just zoom it. Fine. Okay. So you can just go through your, okay. So the first question, why do metals usually look dull even though they are lustrous? As you know, metals, they are having shiny surface. So because they have a shiny surface, then they are called as what? Uh, they are called as this what? Lustrous. Okay, the metal has a property which is called as luster property. Means what? They have a shiny surface. Okay, so even though the metals, they have the property of lustrous, why they look dull? Okay, because these metals, they come in contact with the air. Okay, in air, what is present? Oxygen. Okay, so because of that, these metal will undergo oxidation. Okay, and a oxide layer, okay, a oxidized layer is formed on the metals. So due to this, the metals usually, they look what? They look dull. Okay, they look what? They look dull. Okay, say usually they look dull. Okay, so why metals usually look dull? Because these metals, when they come in contact with the oxygen from the air, okay, they form a oxidized layer. Okay, so they look dull. Next question is, state the properties of metals that lead to making tools like iron, hammer, and axe. So what is the, so we have seen the different properties of metal. So what is the property which is useful for its like to make the tools? Okay, like iron, okay, hammer, and axe. Where we use axe? Axe we use to break the woods. Okay, to break the wood, the axe. Okay, how it looks, axe. So axe is used to break the wood. Okay, so wooden, so like this, the wooden, this will be there, and the axe will be there. Okay, like this axe will be there. Fine. So this is the axe. Fine. So this is the axe. So this is the axe which is used for cutting the wood and all. Then hammer. Okay. Hammer we used to this what? Fix the nail on the wall. So hammer. So why we are making? So what is that property of metal which is helping to make these what metals very what you say strong? Okay, that is due to its hardness. So metals are very hard. Okay, because metals are very hard, so so they can be used in making tools like iron, hammer, and axe. Okay, iron, when you beat uh, iron nails, if you take iron nails or you take irons, okay, these irons, they are used in construction also. Why? Because it will be strong. Okay, because it is very strong because of its hardness. Okay, because of its toughness. So because this is a property of metals, because the metals are very hard, they are used in these tools. Okay, because of this property. Fine. Next is, what is the property of a metal that can be beaten into thin sheets? So we have seen that metals can be converted into thin sheets. Okay, metals can be converted into thin sheets, and this property of converting the metal into thin sheets is called as malleability. What they are called as malleability. Okay, we say that metals are malleable. Why we say metals are malleable? Because they can be converted into thin sheets. Okay, because they can be converted into thin sheets, they are called as what? Malleability. They have a property of malleability. Next, which of the property of gold, because of which it can be used in embroidery, or name the property of metals because of which they can be drawn into thin wire. Yes. So what is the property of metals because of which it can be converted into thin wires, students? We have seen two properties, right? So first we have seen here, see here. So malleability means it can be converted into thin sheets. Okay. And what is other thing where metals can be converted into thin wires is ductility. Okay. So the property wherein of the metal wherein you are converting the metal, okay, into thin wire, they are called as ductility. So what is the answer? It is ductility. So, which is a property of a metals because of which it can be drawn into, or it can be converted into thin wires. It is ductility. Okay, it is ductility. Fine. Okay. Next, what is the property of a metals because of which they are used for making cooking utensil? Yes. So you know that metals, okay, some of the metals we are making use in cooking also, right? For the utensils which we are using, okay, so they are made up of metals. So why, what is the property of that metal? What is the property of the metal? It is good conductors of heat, okay, and they have a high melting point. So what is the property of metals which makes like useful for the metals for cooking purpose? Yes, it is because of their uh, good conductivity towards the heat, okay, and high melting point. So you can cook at any temperature, at a very high temperature also. The food can be cooked in your what in the utensils which is made up of metals, okay. So what is the property of metals which makes which is useful for the cooking purpose in the utensils is due to its good because they are good conductors of heat and they have high melting point and they are have high melting point, okay. Next, give two examples of metals that are poor conductors of heat, that are poor conductors of heat. So which is the metal that is poor conductor of heat? Okay, it is lead and mercury. Okay, lead and mercury, Hg. Okay, remember this. So which are the metals which are having, which are poor conductors of heat? Okay, that is lead and mercury. Is it? So which are the metals which are poor conductors of heat? It is lead and mercury. Okay, remember these. Fine. Okay. Moving forward, seventh question. Aluminium oxide and zinc oxide are known as amphoteric oxide. Give the reason. I hope you are writing down the questions. Yes, I hope you are writing down the important questions. Okay, so aluminium oxide and zinc oxide, they are amphoteric in nature. So give the reason. What do you mean by amphoteric in nature? They can react with acid as well as the base. Okay, amphoteric nature, they can react with both acid as well as the base. Okay, so what is zinc? The aluminium oxide is Al2O3 and zinc oxide is ZnO. Okay, so aluminum oxide and zinc oxide, they exhibit both the properties. They can act as acid also and they can act as base also. Okay, so they can exhibit both the properties. That is, they can exhibit acidic properties also and basic properties also. Okay, then these okay, they react with both acids as well as bases. And when acid and bases react, what do they form, students? They form salt and water. You know that. Okay, acid and base. When they react, they give you salt and water. What they give you? Salt and water. Okay. So aluminium oxide and zinc oxide, as you know, they exhibit both. Okay. Basic character and acidic character. Then second is what? When they react with acids and bases, they produce salt and water. Okay. So remember these things. Okay. So remember these reasons. Fine. Okay. Going for the next question. Sodium and potassium metals are kept immersed in kerosene oil. So if you have visited your laboratory, students, okay, did you see that sodium? Okay, sodium metal is been preserved in a beaker, okay, or in a bottle, okay, a closed bottle or a closed beaker, which is with kerosene. Okay, there is kerosene and your this what sodium metal is preserved in that. Okay, why the sodium is preserved in kerosene oil? Yes, why it is sodium and potassium, why they are kept immersed in kerosene oil? Okay, you might have not seen about potassium, but sodium. Okay, you might have seen sodium is kept in a beaker which is consisting of kerosene oil. Why it is kept, students? Because they are highly reactive. The sodium and potassium, these are alkali metals. Okay, sodium sodium and potassium, they are alkali metals. Okay. So what they do, they are highly reactive. They are what? They are highly reactive. Okay. So because of that, if you keep it open to air, okay, if you keep it open to air, it will catch fire. Okay, it will react rapidly and it may catch fire. So because of that reason, it is kept in the it is stored in the kerosene oil. Okay, so that no any accidental fire is catch up. Okay, no any accidental fire is catch up. Fine. So remember that sodium and potassium, they can react rapidly with air. Okay, and they may catch fire. So it is stored in kerosene oil. Okay, so this is the reason. So remember the reason. Don't forget this. Very important. Next one. A student burns magnesium metal in air. So what does student do? Student take a magnesium wire. Okay, magnesium will be in the form of wire, and okay, and this magnesium metal, it is kept in air. Okay, so what happens as a result of white colored complex? So in air, what is present? Oxygen is present, right? So what happens here? What happens here? So your the student the whatever the magnesium is taken metal, when it reacts with air, it forms what will be the product, students? Can you tell me what will be the product formed here? What will be the product formed? It will be MgO. It will be what? 2MgO. Okay, magnesium oxide. So white color compound X is produced. So what is the white color compound? It is magnesium oxide. So what is the name? It is magnesium oxide. So when magnesium metal reacts with the air, okay, then what is formed? Magnesium oxide is formed. Okay, magnesium oxide is formed. So what is X? White color compound X is produced, and X is nothing but your magnesium oxide. Okay, then what is a B question? So name the compound X. So X is magnesium oxide. Then B question is, what change does an aqueous solution of X cause with litmus paper? Okay, so magnesium oxide, whatever the magnesium oxide is there, if you take a blue, which litmus paper? Suppose if I take a red litmus paper. Okay, if I take the red litmus paper, so what will happen when it reacts with red litmus paper? Red litmus paper, when you react it with MgO, it turns blue. It turns blue litmus. Okay, fine. So why? Because the metallic oxides are basic in nature. Because this is basic in nature. So because of its basic character, your red litmus will be converted into blue. Okay, because it is basic in nature. MgO is having metal. It is a metallic oxide because metal is reacting with oxygen to give you metallic oxide. So magnesium oxide is produced. This magnesium oxide, they are basic in nature. So red litmus paper is converted, or it is turned, okay, into blue litmus color. Okay. So this is the question. Understood till here? Yes. So we have seen now 9 question. Is it clear? Okay. Going for the next question. Atomic numbers of element A and B are 12 and 8 respectively. What type of chemical bond can be formed between these elements? Why? Okay, so there are two elements with the atomic number. There are two elements A and B. Okay, there are two elements A and B. Then the atomic number of A is 12 and atomic number of B is 8. Okay, what type of chemical bond can be formed between these elements A and B? Okay, can you tell me? Try to answer. Try to answer this. So what we are doing, there are two metals A and B. The atomic numbers are given, and what are the, so if which is the metal with atomic number 12? So if I write the electronic configuration of 12, okay, so it will be 1s2, 2s2, 2p6, 3s2, 6, 7, 8, 9, 10, 11, 12. Okay, 3s2. Fine. 6, 7, 8, 9, 10, 11, 12. Then 8, 1s2, 2s2. So this is B. This is A. Okay, so 1s2, 2s2, 2p, 4. 4. Okay, so so it can your A element can donate 2 electrons. Okay, and if it donates this A 2 electron, then it will become a positive ion. Okay, it will become a positive ion. And the electronic configuration of B is what? 1s2, 2s2, 2p4. Okay, so there are how many electrons? So it requires two more electrons. It requires two more electrons. So it can accept 2 electrons and it will become negative ion. So it will be B2 minus. Okay. So you can see that one is taking electron, another is giving electron. So what type of bond is formed? So there will be transfer of electron can takes place. Okay. So when transfer of electron takes place, what type of bond is formed? Ionic bond is formed. Okay. Ionic bond is formed because this is a cation formation and this is a anion formation. Okay, so as you can see, both the ions, they are oppositely charged and thus it forms what? It forms a ionic bond because of the presence of strong electrostatic force of attraction. Because these ions are oppositely charged, okay, because they are oppositely charged. One is positive, one is negative. So a strong electrostatic force of attraction is present between this oppositely charged ions. Okay. So what type of bond it is? It is a ionic bond. Okay. So can you tell me which is the element with atomic number 12? It will be Mg. Okay. And oxygen, the element B with atomic number 8 is oxygen. So it will be MgO. So magnesium, when it gives, it will be Mg plus 2. Oxygen can take 2 electrons. So it will be 2 minus. So the compound formed is MgO. Fine. So this is a ionic bond is present. I hope it is clear. Okay. Moving forward, next question. In electrolytic refining of copper, A, name the materials used in anode and cathode. B, state the appropriate electrolytic solution. And C, where is pure copper deposited? Yes. Try answering this. Yes. So electrolytic refining of copper. Okay. So we have seen the electrolytic refining in copper. So what are the materials which are used in anode and cathode? So so which are the anodes? So the impure metal. Okay, impure metal, whatever the impure metal which is to be purified. So that impure metal will be attached at anode. It will be attached at anode, and the pure metal. Okay. The pure metal is uh, it is attached to cathode. So from this impure metal, whatever the metal is to be, it will get purified and it will go and attach to the cathode. Okay. Now, what is the electrolytic solution? The electrolytic solution is copper sulfate solution. Okay, it is copper sulfate solution. Okay, so remember this: impure metal is anode, pure metal is cathode. And then what is the electrolytic solution? Copper sulfate is a electrolytic solution. And where the pure metal will get deposited? Where the pure metal will get deposited? The pure metal will get deposited at cathode. So you can see. So from impure metal will be at anode. So what will happen? Whatever the after purifying, after the electrolytic refining starts, okay, whatever the pure from impure metal, the metal pure metal will be getting slowly, it will get deposited on the from impure to pure metal of the copper. Okay. So the pure metal will get deposited at cathode, because at cathode pure metal electrode will be present. Okay. I hope you are getting the things. Okay. So please note down the questions so that it will be very easy for you for your preparation. Fine. Moving forward. Next question. Metal sulfides and your carbonates. Okay. Metal sulfides and carbonates. They are converted into metal oxides. Metal sulfide and carbonates. Metal sulfides and carbonates. Metal sulfides and carbonates, they are converted into metal oxide during extraction of metals from their ores. Give the reason. Yes, can you give the reason? So we have seen that, okay, when you are doing the this when the metals, okay, when the metals are of middle reactivity, okay, when the metals are of middle reactivity, then it is very difficult to extract it in its oxide form. So what is done? The metals are converted, okay, it can be easily extracted from sulfide and carbonate. So what is done in that method? So the oxides are converted into its sulfide and carbonate form, okay, and they can be extracted well. So this is one point. Another is oxygen can be easily reduced from metal oxides by reduction. So whatever the oxygen is present, it can be easily reduced from its metal oxides after reduction. So these are the 2 points. Okay. So these are the 2 reasons. Next question. Generally, metals react with acids to release hydrogen gas. You know that whenever metals, they react with gas. Okay. Then what is released? Hydrogen gas is released. But when reacted with nitric acid, no hydrogen gas is released. Why? What is the reason? Yes, students, what is the reason? Try answering. Try answering. So if I take a metal like zinc, if I react with hydrochloric acid, okay, so this is a dilute hydrochloric acid. Zinc is a metal. Okay, so if I react the zinc metal with zinc, that is dilute hydrochloric acid, what is formed? ZnSO4, okay, plus hydrogen gas is liberated. And what? Hydrogen gas is liberated. You can see hydrogen gas is liberated. Same way with sodium. If I take sodium metal, okay, and I react it with hydrochloric, this, you get NaSO4 plus hydrogen gases liberated. Okay. Then again, can you give other examples? So like this, okay, whichever the reactive metals are there, so when they react with acids, okay, then they will liberate what? They will liberate hydrogen gas. But when they react with nitric acid, what is nitric acid? HNO3. Okay. So they do not release hydrogen gas. What is the reason? So with other acids like HCl, hydrochloric acid, they will release hydrogen gas. But when they react with nitric acid, they do not produce hydrogen gas. What is the reason? So metals except manganese and magnesium. Okay. So except these magnesium and manganese, Mn and Mg. So these will react with hydrogen gas. Okay. So metals like magnesium and manganese, they do not release. Okay. That is except these. So these will react with your nitric acid and they release hydrogen gas. But other metals, when they react with acids, they do not release hydrogen gas with nitric acid because nitric acid is strong oxidizing agent. Okay, what is the reason? Nitric acid is strong oxidizing agent. It oxidizes the hydrogen produced to water. So what is done? Whatever the hydrogen is produced, okay, it will be oxidized and it will form water. Okay, so this is the reason. Next is nitric acid itself is reduced to any of the nitrogen oxide. So HNO3, what it will do? It will be reduced to NO2. Suppose it can be reduced to NO2. So it itself will be converted into its oxide. Okay, it will be reduced to its oxide form. So this is the uh, answer. Okay, so this is the answer you have to write. So other metals, they will react with all the this what they will react with the acid to release hydrogen gas. But when other metals, when they react with nitric acid, they do not produce hydrogen gas. Okay, so metals, they do not release hydrogen gas. Okay, with nitric acid. So these are the reason. Firstly, it is strong oxidizing agent. Secondly, hydrogen itself will undergo oxidation and it forms water. So because of this, the hydrogen gas won't be liberated, itself will be converted into water molecule. And the third reason is the nitric acid itself will undergo reduction and it will form its nitrogen oxides. Okay, it will be reduced to its oxide. So this is the reason. Fine. Next question. Reaction between compound X and aluminum is used to join railway tracks. Yes, so this is thermite reaction. This is called as thermite reaction. Okay, in joining the railway. Okay. So in joining the railway tracks, okay, we are using this thermite reaction. Okay. So what is the compound X? It is Fe2O3. It is Fe2O3. Okay. So compound X is iron oxide. Fine. What is the compound X? It is iron oxide. Name the chemical reaction involved. So it is called as thermite reaction. So this is very important. Please keep in mind which is a compound X. It is Fe2O3. Which is the chemical reaction involved? It is thermite reaction. Okay. So which is the compound X? It is Fe2O3. What is the chemical reaction involved? Fe2O3. Chemical reaction is thermite reaction, and write the chemical equation between the compound X and aluminium. So the chemical reaction goes like this: Fe2O3 solid, when it reacts with aluminium metal, okay, it forms 2FeL plus Al2O3S plus heat. Understood? So this is the reaction. Okay. So next question. Next question is allotropes of a metal, non-metal, allotropes of a non-metal X and Y and Z. X is the hardest natural substance. and Z is the conductor of electricity. Okay. So identify X, Y, and Z. So allotropes of a non-metal X are Y and Z. So a non-metal is there, which is a non-metal. It is carbon. Okay. So what are its allotrope? X and Z. So X is the hardest natural substance and Z is the conductor of electricity. So what is that? So X is your carbon. X is the non-metal, which is carbon, and which is the hardest. Y is your diamond. Okay, because it is the hardest metal, and Z is your graphite. So graphite, why it is conductor of electricity? Because here the carbon is sp2 hybridized and there is one unpaired electron. So there will be one unpaired electron. Okay, and this one unpaired electron, it will be what? This one unpaired electron will be responsible for its conduction of electricity. Okay. Fine. So these are the allotropes. What do you mean by allotropes? Allotropes means what? Allotropes. Yes, students, what do you mean by allotropes? Can you tell me? Can anyone tell me what do you mean by allotropes? What are the allotropes of carbon? Allotropes means what? Allotropy, it is a property of chemical elements, okay? So that it will be existed in two or more forms, different forms, okay? Their physical state will be same, but their chemical properties will be different. For example, carbon. So carbon is a non-metal. Its allotropes are diamond and graphite. Diamond is the hardest, you know, diamonds where it is used, okay, in ornaments and all, in finger rings and all diamonds are used. Graphite is used in pencil. So this graphite here in diamond, the carbon is sp3 hybridized and graphite is sp2 hybridized. Okay, so your one electron will be unpaired electron is present. So this is responsible for its conduction of electricity. So graphite is a good conductor of heat and electricity. Okay, fine. Next question. Name the components of solder. Why are these metals used as solder? So what are the solder is nothing but it is a alloy. Okay, it is a alloy. Okay, alloy we know it is a homogeneous mixture of two metals or two non-metals. Okay, so here what is a solder? Solder is a alloy which is made up of lead and tin. It is made up of lead and tin. Okay, then these metals, why these metals are used in solders? Because they have a low melting point. Because of the low melting point, they are used in solders. Is it clear? Yes. Is it clear? So these were the questions. Okay, there are a few more questions. So these questions we will take it in the next class. Okay, so we have seen 16 questions till now. Is it clear? Any doubts? So whatever the things are told, is it clear? Any doubts up to here? So if you have any doubts, you can ask me in the chat box. Okay, you can drop your message in the chat box and you can ask me there. Yes, that only what name the components of solder. Solder is what? Solder is a alloy. What is alloy? Alloy is a homogeneous mixture, okay, which is made up of two metals or two non-metals. Okay. So here solder is a alloy. So which is the two metals? So it is made up of lead and tin. It is made up of lead and tin. So this is the first answer. So what are the components of solders? Lead and tin. Okay. So these are the component of solder. Why are these metals used in soldering? Okay, So why it is used in soldering? Because they are having very low melting point. Because of the low melting point, okay, these are used in soldering. Fine. So we have seen till 16th. Okay. So 17th, 18th, 19th, 20th, and 21st. So this will be seeing in the next class. Okay. Is it clear? Any doubt still here? So we have solved till 16th. Okay. Any doubt till 16th questions? So these are very simple, small questions, okay, based on the properties, okay, based on the properties and the reaction, chemical reactivity. Fine. Okay. Any more doubts, students? Okay. So I shall end the session here. So we'll meet in the next class. Thank you. Have a good weekend.